So building off of that similar script with using this kind of enclosed curve, we're going to, again, just use a standard rectangle, but give it a lot of variation. The idea is that this can now be almost treated like a planter seating, so you could have some type of landscape vegetation on the inside, but then being wrapped around a seating, but still have it accessible and functional as well, which will be pretty interesting. So I'm going to, again, take this curve and reference it. And again, I'm going to start to determine how dense I want this with these profile curves. So I'm going to go to curve, divide, give it a value. Right? So this will dictate how dense it is. It can be a little less than that for now. From here, again, I want to find the horizontal frames for these. And this way we want to at least start off with it to be a little dense so that we can take this to deconstruct or reconstruct another plane. I know it's kind of a tedious process, but at least it'll make sure that our results are always what we want them to be. Because again, these things can start to shift directions and orientation, which will just throw it all off and might even crash your script. So we want to just ensure that we don't have that issue. So again, the z of these ones is my y. That's my origin. And then the y is the x, but I want it to go in the other direction. So negative x. You'll see from here, now we got them all facing in the right way. So we always kind of want whatever the direction of that seating to go to be pointing outward. So now, like I said, I can start to use this plane to create a rectangle. So again, instead of our own custom shape, we can just use a standard rectangle. And in this case, we want to, again, give it a lot of variation. So I'm going to use the graph mapper to give both the x and the y those changes. So again, it's very similar to several videos now. So now we are going to, again, use the sets to create a range of values. Again, 11 and 11. Oops, so you can see that, when I just divide this curve, I'm getting 10 values versus this is giving me 11. So I need to make sure that this expression is x minus 1 so that I get the same number of outputs for both of these. Again, it's one of those things where sometimes you have to ensure that we're getting the same number of outputs from both of these. So again, I'll use the graph mapper. And I'm going to use the sine graph so I can have this kind of wave condition to it. And again, I just want that to be start off for the x, but it's going to start off at 0, which is fine if I just drag this into there to be these varying widths. So I probably don't want it to ever be 0, so I could always just say, at the minimum I ever want it to be is 1, and maybe the max width is like 3, so that way you can have like double seating. Right, so this is just the width for now. The next key element is the height. So again, I'm just going to use the same process, except in this case I do want the y to start at 0, so some cases it's perfectly flush with the ground plane, and then the height probably don't want it to go much more than 1.5 or 18 inches, so it's actually can be sat on, right? So here we go. Now we have that kind of interesting variation, right? So let's make sure that this one is gonna be okay. I guess so, yeah, it's 0. We'll see. The next thing you just want to do is now go ahead and loft these, right? So then so that there's no kind of segment there, let's go ahead and say loft options, close loft, commit changes. So there you go. So it's a little kind of extreme right there. So you can always just kind of mess around with uh, these values. Maybe you want there to be more of these kind of waves to it, right? So now we're getting some pretty kind of interesting results of this kind of undulating uh, planter. So again, the y is going to dictate the height, right? The number of kind of waves we want. Then the x determines how often does this kind of deviate from uh, 1 foot to uh, 3 feet. So there you go. So that's kind of an interesting form. But again, we kind of want to, we've taken care of the ability of like accessibility, right? These areas where it comes to the back to grade allows for people to walk into it. But if we also want to kind of think about functionality, if this is some type of vegetation, maybe we also want some additional curb cuts, basically, or slices through this to um, allow for water to also drain into it. It kind of takes away from this kind of massive concrete volume as well, which is nice. So basically what I can do is continue to use my planes here to help uh, create physical slices through this. So what I want to do is again use these planes to again create another rectangle. And I'm again going to just treat this as something like I'm physically slicing through it. So I have to make sure that these rectangles that are going to be cutting through it are completely intersecting with it. So I think the height is okay, so the y. Now I just need to make sure that the x is always going to be long enough, and both directions too, right? So math, construct domain, the a is going to be a negative value, so that's going in both directions. The b will stay positive. So I'll do something like 3. That should give us plenty of clearance to cut through these things. Right? Let's just think, yeah, in some areas it's slightly wider than 3, or right at 3. So we want to make sure that we take care of it. So now you can start to see that these things are going to physically intersect with that. So now we can determine how thick you want those slices to be. So again, I'm going to go ahead and let's turn off some of these things so I can see it a little better. I want to make these a planar surface. So that way I can extrude these to make them have some volume. So let's extrude. And again, it needs a direction, so I can't just give it a standard direction. I want to use these planes to give me the direction. In this case, we see that the x and the y are on these green and red axes, but the z is the blue, which is always never shows it, but we can use the z-axis of this to figure that out. So I'm going to again have to deconstruct this and use the z direction, but give it again some thickness, so I want to give it an amplitude. So z is the direction, And I can use a number slider, so I'll do something like 0.5 less than 3 to determine how thick I want these to be, right? And these are all, at this point, going to be kind of uniform. So we can start to kind of take it in two directions at this point. We could have them, again, kind of all have equal distances, or we could even start to randomize where these start to get cut. So I can actually use this original curve, stick in the vectors and populate this with a random set of geometries. So again, I can determine how many I want. Probably don't need 100, which is what the default is. Right, so now we can see that the spacing of these points is a little more sporadic. We can always play with the seed as well to determine what that kind of randomization is. And then from here, again, it's kind of similar to this where I created points, but I, again, want to use the curve closest point to get my t parameter. So curve points, right? So this is the key thing we want to use. That way we can just simply copy and paste this. So again, the same curve, just different parameters. Right, so that can be that. And so instead of having them all uniform, if I want, I can also make them randomized, right? So I can determine if I want less of these cuts, where those cuts are, right? Kind of randomized. I could even give a range of different extrusions, right? They don't all have to be the same thickness, which is kind of interesting as well. So maybe again, I want to create some random thicknesses. So that's what half is. Don't know if I really want to get it too wide. Maybe it's somewhere, they range somewhere between 0.5 and, I don't know, let's see what happens if I have some that are randomly at 1.5. So I'll go to sets and use this random. So the range of values, again, I want those to be between 0.5 and 1.5. So these can start to be these random values. I can also start to determine how many of these random values I have. So basically if I want them to all have the same, all to be unique, so I can just use the same number slider that's going into the number of random points for that, right? So now they're all unique. So we finally kind of figured out what these cutting objects are going to be. And now we want to actually start to, again, physically separate them. So you can go to intersection, shape, and use the solid difference. So this lofted surface is the A. So this is the object I'm subtracting from. And I'm using these to subtract it. And now I can turn off all of this, and luckily it didn't seem too complicated for it. But now we got, again, our kind of randomized planter seeding, which has, again, obviously things like this, maybe not necessary, but maybe there's some other kind of logic to that, whether it has to tie in more with the landscape since it's perfectly at grade with the existing part. So a lot of kind of interesting things we can start to have to kind of break up the solid mass, allow for there to be accessibility and also this functionality to it as well. And it's kind of cool where, like I said, it seemed like it handled it pretty well. So maybe if I just mess with this, I can start to see all sorts of different options coming out of this. So yeah, it gives you a lot of versatility and variety in a planter seeding.